Friday.
Yeah.
Oh, good.
Quicker. They're distributed. And Jen took care of that. She was here way early, much earlier than me this time. No, it's
Friday afternoon.
yeah, and it's nice weather today too. So. You can just go ahead and do something, I guess. Yeah, do you want?
Good morning, crowding. It's quite empty, but people are coming, so we're going to start. First presenter, please. Shinsuke. Oh, this is an PDF. It's not going to work.
Okay. Hello, everyone. I'm Shunsuke Homa from NTT. I'll talk about network slicing provision model. This draft is new, and I will talk about background and the overview of the contents of this draft. Also, notice that slicing will include several factors such as operation and dead plane manipulation. And I presented this in Ops area working group yesterday. So,
does it work? I will do it for you.
Okay. Oh.
It's a PowerPoint.
So as you know, network slicing is a hot topic, and I assume that there are several factors. For example, diversity of devices and services with communications, or improvement on flexibility of network control presented by network virtualization technologies such as NFV and SDN. Also, network slicing is a fundamental concept of 5G, and 5G will be launched soon.
Just tell us when.
Oh, okay. Next slide, please. So network slicing is related to 5G. So ITU and 3GPP defined three communication types as features of 5G: EMBB, MTC, and URLC. And network slicing appears on this context, but we would like to aim more general concept on network slicing. Next slide. So, and there are several problems. For example, network slicing is discussed in several SDOs, but their definitions seems vary. For example, some SDOs says S-slice is just VPN, but another says slicing will be VNF and self-chaining. Also, the range where slice is provided is not strictly defined. For example, 3GPP discussing just using slices within just a 5G core network, but we would like to realize slice from end to end. Also, there is one more problem. It is usage of slice is unclear. For example, slice will be used for enriching operators service plans, or it is used for providing dedicated logical networks to tenants. So we would like to aim at the later one. So next slide. In the following two slides, I will talk about the scope and purpose of this work and this draft. So we would like to aim a sweet spot for each service, like this figure, not only edge of the triangle. So this enables tenants to use appropriate network resources depending on their service, and provide their service and network resources as their own service. So, and we would like to, we have mainly two purposes on this draft. So first is defining resource types, structuring network slices, and stakeholders and their role in network slice as a service models. It would be a fundamental reference for individual internet drafts related to slicing. Also, we would like to clarify capabilities required by tenants, and how to provide such resources to the tenant. Okay. So in the following few slides, I will explain the overview of the contents of this draft. So firstly, this draft defines resource types. So we assume that there are resources can be categorized three variations. So first is network or one resource, such as connectivity expressed with link or node, or data plane protocol, etc. Second is computing or NFVI resources, such as CPU, memory, storage. And we think functionality will be required for network slicing as a resource. Also, network slicing should cover both virtual and physical resources. Next slide. So this slide shows the basic structure of network slicing with referring 3GPP or TM forum definitions. So network slice subnet instance is derived in each domain with such resources. And by connecting these subnet instance, end-to-end network slice instance will be created. Also, sometimes network slice instance may be a multi-level structure. So this slide shows the creation pattern. This is one of the main contents of this draft. So we categorize creation pattern of network slicing into three patterns. So first is a ready-made pattern. In this pattern, network slice provider creates slice catalog in advance, and tenant select one, which is close to demand. So this is very similar with current network service. Second is a custom-made model. So in this pattern, so network slice provider design a catalog depending on requirements from tenants dynamically. It's very challenging model. And third is the semi-custom made model. And this is hybrid of ready-made and custom-made. So in this model, network slice provider creates outline of catalog, and tenant input some parameter depending on their service requirements. Next slide. So this slide shows the provision models which is defined in this draft. So we categorize the provision model into three models. So first is SaaS-like model. In this model, so very detailed network resources is hidden from tenant, and the tenant requests its own just requirement and created appropriate slice automatically. So second is a path-like. In this model, tenant can control virtual resources like middle or right side figure. And last is IaaS-like model. In this model, so tenant can control underlay infrastructure dynamically and create their own slice. So next steps of this work. So this is new one, and we have very few feedback, and we will welcome more feedback. And especially, we would like to know opinions from vertical customers. And second is mapping such budget provision models and controllable resources. And finally, if needed, we would like to expand the current YAM models. So, okay, that's all.
Greg Mirsky, CT. I realize that now it becomes my kind of usual question in RTGWG. How this work related to the work at MEF?
Sorry.
Because MEF LSO committee has a network slicing LSO active project, which is very much what you're planning to do. They are doing already.
I don't think slicing is just for 5G. We would like to apply slicing for every types of networks. So
yes, that's what part of model in LSO net slicing at MEF. So okay, let me rephrase the question. Have you looked at what they're doing?
Sorry?
Have you looked what LSO network slicing at MEF project has achieved so far?
So it's just my opinion, but I would like to make a platform for providing appropriate resources to vertical customers, and so to accelerate B2B2X model. So.
I think it's a good thing to somehow check what other SDOs are doing and not to do the duplicate work. And one of the ways to resolve that and clarify that is to send liaison. So I think that before we start discussion, it would be good to set liaison and ask LSO network slicing project to review and explicitly describe what they're doing and where they are. This work has been done already for some time, and there's some good progress on it.
Okay, so I'll confirm the past work.
So procedurally, we would send liaison or request one after we've decided to adopt this work. As of now, it's just a draft.
Okay, then it's just suggestion to offers to verify if somebody works for the company, which is MEF member, they can go to the committee, LSO committee, and then look for the active projects for network slicing and review contributions in the current version of their working document.
Okay, thank you.
Sure, and looking at a list of co-authors, some of them are definitely involved in the MEF work. So
I agree, yes, I would assume so. Yeah, it would not be that hard.
So it would be good if you indeed look at LSO. From my perspective, it's higher levels. That's what you are trying to achieve. So there's could be some synergy, and it would be good if you could review and see the differences and where their work stops and ours starts.
So I don't think we shouldn't. I don't think we need different work frame from other SEOs. So we need unified over all of SDO. So yeah,
I agree with you. I'm just asking you to review.
Yeah, I adjust this draft for other SEO's definitions.
Robin from Huawei, quick suggestion. I think that's in the TIS working group. There are some network slicing work. Yeah, it can be aligned.
Yeah, it will be used for slicing.
Yeah. So that's I say that's
so,
now.
But slicing includes other factors, for example, service chaining or VNF control, in addition to VPN service.
Yeah.
So how to we would like to clarify how to integrate these resources.
Yeah, I know. So I just mentioned that in the TIS working group, there's some the existing work. It's the presentation or trigger the discussion here. That will be helpful for this one.
Yeah. Okay.
Okay.
Yeah. Thank you.
So, and there are not only TIS, there's a number of working groups trying to cover different aspects of net slicing. We've got a number of both, so there's a lot of work going on. And we are aware of it. Thank you.
Okay, thank you.
Linda?
Good morning. Okay, so this is our second time presenting this document. Actually, two documents which have been adopted by the RTG working group draft. Thank you, everybody. So we did some update.
Should work.
No, it's not working. Okay, so the problem statement are pretty much stable. And for the gap analysis, we did more update, and we also had like 2 hours discussion with some of the other initiatives on Wednesday. And so I'm just report them to all to here. Okay, so does it work? Yes. Okay, so for the SD-WAN, we further separate them into two separate kinds. One is the homogeneous SD-WAN, which is like if you instantiate a small CPE box in a shopping mall, in a dental office, and you want to connect the traffic to your corporate VPN, so that you need to be able to create different type of secure channel between the attached client routes to the other PEs. That's one type of SD-WAN. For this SD-WAN, all the client traffic are encrypted, and they don't really care which egress port to use. The second we call hybrid SD-WAN, in a way that this particular CPE probably already have interconnection with the provider VPN, but add additional ports to connect to the internet. That can be on-prem CPE being upgraded to utilize the bandwidth on the internet or LTE. Could be you instantiate virtual router inside a cloud data center. Say if you have a cloud data center, you like use AWS as an example because everybody's familiar with that cloud services. You instantiate a virtual router, and one port you use direct connect, which is directly connected to your corporate VPN. Another port is connected to the virtual gateway, internet gateway, so that you can utilize both bandwidth and you can differentiate traffic for different egress port. So the The difference between those two is on the WAN port management. So in the hybrid SD-WAN, some of the traffic can have to go through the private VPN, doesn't matter what. So they have a policy on the device. Certain traffic have to go through the private network unencrypted, because encryption is very processing intensive. So for the traffic goes through the private network, it can go natively. Another part is some traffic can be either, right? Some traffic has a choice of, you can go through private network unencrypted, or you can go through the public network, but that have to be encrypted. So another part is because those devices are far away from other devices, and also the connection to the controller. Here we use route reflector because they are for forwarding, propagate the routes, can be going through the untrusted domain. So that's very different from our traditional VPN. So first, when a node powers up, not only he need to figure out who is his controller, but also need to be able to establish a TLS session with the controller. After you establish the connection with the controller, you need to be able to register your WAN port before your IPsec tunnel can be established. This is almost like the function like NHRP. I think Andy was the chair for that 20 years ago, for the ATM port. But this one, to manage the IP traffic, managing the different IP routes, has to be extended. But we think that it's probably better to use BGP to do the propagation of those WAN port properties instead of introducing a new protocol or make enhancement to the new protocol. So that's part of the gap, not there yet. And we actually put together a draft in the IDR, a working group, just for that purpose, for the WAN port management. When one node powers up, it establishes the TLS with its controller and report their WAN port properties, which can be a private address or could be dynamically assigned address by the ISPs, and also report the loopback address. And then the controller propagate that information to the authorized peers. Because the node themselves doesn't know who he's entitled to talk to or authorized to talk to. So it is the controller which actually propagate to the authenticated authorized peers. Okay, so further on the gap analysis, in addition to what we presented last time, here's something new. We plan to use, we think the tunnel in cab draft, the base should be used for advertise the port properties or advertise the route with the tunnels. But as of now, at least as of now, the tunnel in cab draft is associated with the client routes. Like in example here, 20.1 can use particular tunnel, can use VXLAN tunnel or can use IPsec tunnel. But it doesn't address the issues of, like, see, I have a WAN port, like here, the A2 or A3. This particular port has those properties, right? I have the private address, I have public address, I have the net associated with this port, and I want to establish IPsec tunnel between A2 and B3. Say A2 maybe by the ISP1, like AT&T, B2 maybe in a different country by China Telecom. So those two have different assigned IP addresses, and the loopback address is in a different address space, right? The loopback address is in the space of the overlay layer. So as of now, we talked on Wednesday about this, and the authors agreed to add, hopefully they will add, basically allow the tunnel in cap to be able to advertise the tunnel with, say, a loopback address, or maybe with the WAN port address. So those can be used to identify, to propagate the properties of the port and advertise the mapping between private address and public address. So with that, then see if we have 4 routes in this example. The 4 routes, maybe 20.1 can go through all 3 egress ports. And then that one has to be able to recursively being advertised. I can go through those 3 egress WAN ports. They don't have to repeat all those WAN port properties in each of the update. Like maybe the 20.2 can only egress 2 ports or maybe 1 port. Then he can advertise that with indication of the specific port, and doesn't have to repeat the tunnel detailed information. So all those has to be, it's not there yet. That's the gap we have identified. And also that, say if the route can aggregate, can egress 3 different ports. As of today, based on the read of how the in-cap draft is written, it seems like you need to include 3 different remote endpoint sub-TLVs. But then the draft itself also indicated that you cannot have more than 1. So there's some kind of inconsistency in the draft. So that's on the tunnel in-cap, the gap. Next one. This part, I'm just reiterate about the WAN port management. After node powers up, it create TLS session with the controller. And the first thing it need to do is to tell the controller, what are my WAN ports? I have 3 WAN ports. I have 2 WAN ports. My 1 WAN port is connected to the private network. My 2 WAN ports is connected to the public internet. And my WAN port can be supporting MPLS, or maybe I'm just doing a standard CPE, which is just IP or Ethernet handoff. And who's my loopback address? Who's my net outside the WAN port? So we call this registration extension for BGP. And in the BGP IDR group, we introduced a new NLRI just for the WAN port management. And some people did ask on the mailing list that why can't we use the netcomp to do this job? The problem with netcomp is it doesn't, it's not easy for the node himself to report. And especially when you change, you have to report dynamically every time the port address change or property change. And another important part is to be able to propagate to the authorized peers. So that, say, if a CPE1 can talk to CPE2, CPE3 in different cities, then they need the route reflector to propagate them with the proper policy identified. Okay, I see the IDR chair speaking.
Oh, no, that's okay. In this one individual, Susan here's individual contributor. I just want to perhaps put a slight spin on what Linda just said about netcomp. The notif stuff is really useful, or the push notification, but it's just finishing. So, you know, it's a little bit of time to the deployment. So in many cases, some things we're doing are just saying, okay, we got to have these sort of things so that the managements can still continue and be easy. Some of that feedback is from product groups. I hope the notification stuff, and I think Linda does too, comes and is out there widely. We're dealing with this interim period.
Thank you. Okay, next page. Okay, so we see that for SD-WAN control plan, there are actually 3 different components, just to wrap up on the control plan part. The first part is the WAN port management, being able to report the WAN port properties dynamically. The second part is for the IPsec configurations. The traditional IPsec manual configuration or peer-to-peer negotiation doesn't scale when you have more than 100 nodes, because each node need to establish multiple IPsec sessions. Having those peer-to-peer negotiation just doesn't scale. So that part, there's a draft in the IPsec ME, talk about that. Then the third part is our traditional EVPN, L3 VPN, the route propagation, right? So there are three different parts for the SD-WAN. And the third part has been studied really well. We have RFCs, we have protocols to address that. For the first and second, that's the two parts which IETF haven't done yet. Hopefully, we will have proposals for those. The first part, we already have one proposal. And second part, there's a proposal in the security area. Okay, next one. Then this is my last page. I sat in the IRTF open session, listening to this Fabric Edge presentation. I just borrowed their picture. It's indicated that like in BGP is widely used today, right? Between AES domain, between cloud provider, and when the cloud provider, say AWS, you initiate the virtual router, you exchange the AS number, but it doesn't, the BGP itself doesn't have the performance characteristics, right? So you see, I can reach from this route, but maybe my immediate link is wide open. I have two possible ways to reach my destination. My immediate ports, I can test the available link utilization. Maybe link 1 is very little utilized, link 2 is heavily utilized. But I don't know after one hop, maybe after the second hop, and link 1's maybe bandwidth is heavily utilized. So the BGP doesn't have any of those indicators. So in their paper, they talk about some ways to mitigate that. And I recommend people to maybe go back to listen to the video or look at the presentation. I find that is another gap which are needed for SD-WAN's intelligent path selection. I think that's it. That's the end. Oh, the next step. Okay, so here I just listed all the relevant drafts for this domain. In the routing area, we have secure EVPN, we have secure L3 VPN. They talk about how do we stretch a PE far away through the untrusted domain. And there's also the IDR, talking about a new NRI for the WAN port management. And then in the security area, there's IPsec ME on the SDN controlled key, read key management, because IPsec the key need to be refreshed periodically. If you let every node to refresh key on their own frequency, a node can, maybe if you have 10 IPsec tunnels, and you have to go through lots of process. So that draft basically document how do you do the SDN controlled the read key. Then there's I2NSF, talk about initial configuration, like when the node powers up for the IPsec basic configuration, you have two cases. One is IK-based configuration by controller. Another one is IK-less, just assuming the node is the IoT device, doesn't have a power to handle the IK, IKv2, then what are the procedures to do the initial configuration? So that is in the I2NSF. And there's also the, in the ops area, there's SD-WAN service model. I forgot to list, there's another data model being listed in the RTG working group, which was presented last session, is more about inter-vendor exchange, because that is under the assumption that all the SD-WAN deployment are single vendor domain. So when the traffic cross the vendor domain, what kind of pass information need to be exchanged? So there was a draft for the RTG working group. In the ops area, is more from the operator's perspective. The operator's perspective is about, okay, from operator want to set up the SD-WAN, I may have different vendors, but how I do it from client perspective, what kind of policy he wants, how do we want to set up the peer association. So a different angle. So the ops working groups, the data model is more aligned with MEF's model, which is like from service provider perspective. The one being presented at RTG working group on third Tuesday, right? That was more from vendor perspective. Say if you are an enterprise and you buy vendor A's devices, and maybe your traffic need to exchange with another vendor. So that's more from the vendor perspective. So two different perspectives. They have two different data models, service models. So all those are the relevant activities. I just want to bring people to be aware of all the activities. Thank you. Any questions?
I just had a general question about sort of how the focus of the two documents, the problem statement and the gap analysis, because the gap analysis document really focuses on SD-WAN generically and not so much the idea of connecting an SD-WAN to a cloud. Mm-hmm. To some extent, it seems to be providing the framework for a lot of protocol work that you're doing to eventually allow SD-WAN solutions to be, standard and not. Right now, most SD-WAN solutions are sort of have proprietary glue in them.
Right.
Is that an accurate assessment?
Yes.
So, but the title of the documents is somewhat misleading then.
Oh, okay. So the intention is really because when you see SD-WAN, many people interpret it as just a two branch office interconnect with two links. That's very narrowly scoped. And we call it a network to cloud data center. It's more about how do we interconnect the underlay network with the cloud data center, where is the main drive now for SD-WAN. SD-WAN has been in the market for maybe 6-7 years. Initially started with, I can deploy a cheap box to aggregate all the bandwidth together, but that never really fly well in the industry. Has deployment, but deployment is very little. And as of now, like for example, in ONOG, many of the enterprises stated that the reason we need SD-WAN is not because we want it cheap or we want a low cost. Is primarily for us to have a way to reach cloud workload in the cloud anywhere, any place. So when you reach the workload in the cloud data center, you have to go through your underlay network for sure. Like from your enterprise out, you have to go through an underlay network. Then you have to go over to the internet, the overlay. So the reason we call it network to cloud DC is because of to emphasize the focus SD-WAN is not just branch office interconnection.
Right. However, the actual focus and text in the gap analysis document, a lot of the examples are, and I'm not suggesting you change the examples to be, cloud connected, but a lot of them are simply SD-WAN without, involving the particulars of the cloud. And I think it's useful regardless. I worry that people won't, just looking at the title, won't necessarily know where to look.
Okay.
Right.
So maybe we should add a section like to reach to the cloud, what are the gaps? Because that is definitely needed by the industry.
So I agree with Chris on this point, and there's a lot of focus on bootstrapping, not traversal, this kind of stuff that's not really cloudy stuff, right? So it would be good if you put maybe a bit more text and examples with regards to what requires to connect to SaaS services. Because in a lot of cases, you just break out, right? So to define these models, how people do connect from SD-WAN domain into cloud domain.
Okay.
It's not well spelled here. From editorial perspective, you're relying on a lot of work done in other places in IETF. Please make sure anytime you do so, have a reference so a reader can easily go and kind of recursively read the technical details.
Okay. Thank you. Thank you very much.
Mom? Maybe it's not on. This is stupid. We forgot to switch it on.
Okay, you should be good here.
Could you please try? It's PowerPoint again.
Okay.
We'll do it for you.
Wait a second.
Oh, it's the wrong slide, so.
This
Yeah,
was
sorry.
for the next one.
Yeah, this one.
Hi everyone. Today I'm I'm Huaimo from Huawei. Today I'm going to talk about the SRv6 pass egress protection. So right now we have SR pass fast protection, which provides fast protection for transit node. So this draft will propose solutions which will provide fast protection for the egress node of SRv6 pass. So let's have a look about SRv6 egress fast protection. So in this picture, we have SR pass, which is from PE1, P1, and PE3. So PE3 is the egress of this SR pass. So this SR pass will carry VPN traffic. So this traffic will go through from ingress PE1 to P1 and then to PE3. So when PE3 receives the package with a VPN ID, so PE3 will use that VPN ID to deliver the traffic to the CE2. So in order to provide, so that's a normal operation. So in order to provide egress protection, so we need to do more work. Here we need to configure the mirror SID to protect the egress PE3. So in more details, we need to configure mirror ID. For example, give the mirror ID here, and then protect the locator, which is associated with PE3. So with this information and the other information, such as the VPN routes, and then with those information, PE4 will create a mapping, which will mapping that mirror ID with the VPN ID, which is associated with PE3, mapping that one to the local VPN IDs. Because those kind of mirror ID and locator, which is mirror ID protected, will also distribute in the network. So when P1, which is the upstream hop of egress node PE3, receives those informations, it will compute backup path from PE1 to the backup egress node PE4. So with those backup paths, and also it will check update those forwardings on the PE1. So with those information, as soon as PE3 fails PE1 will detect the failure and then will send the traffic to the backup egress node PE4. So when PE1 send those packages to backup egress node PE4, it will push that mirror SID. So this package with mirror SID will send to PE4. So after PE4 receive the package with those mirror ID and also the VPN ID associated with PE3, and then PE4 will use those information to map those package map to the local VPN SID. So using local VPN SID will deliver that traffic to the same CE2. So that's the idea about the egress protection. So here, in order to provide egress protection, so we need to distribute the mirror ID and locators, which is protected, which is to be protected by the mirror ID. So the next is the protocol extensions to distribute those informations. So regarding the protocol extension, and we need to extend to ISS, and similarly, and OSPF. So for ISS, the extension is simple, and then we just define a new sub-TLV. So this new sub-TLV is in the SRv6 locator TLV. So this sub-TLV basically will contains the mirror ID and then some sub-TLV. So most here we just define the two sub-TLVs under this sub-TLV. So one is a locator sub-TLV, is the locator, and then which is to be protected by the mirror ID. And also we may have the protector, the other protectors, IDs to be protected by the mirror ID. So that's the extension to ISS. Similarly, we have extensions to OSPF. So any comments and questions?
Okay. Greg Merskiziti, couple of reflections. Well, it's like deja vu. I recall we had a similar discussion on RSVP LSP egress protection. That's one. The second one is that I think that would be good to get more strong case why it's you consider it useful, because you're effectively changing the paradigm or benefit of SR not creating the state in a transit node.
Yeah, regarding to first question, yeah, we have RFC, and I'm the main author of that RFC for provide egress protections. Yeah, that's I think it's maybe some kind of similarities. Yeah, maybe we can add some reference here in the draft. Regarding the second question, and then we add some states in the midpoint. Yes, because we need want more functions, so we need more work, right?
Well, that's the question. So I think that first we need to discuss whether we need it or not.
Yeah, that's a good question. I think whether we need it or not, I think there's customers need this kind of functions.
Well, if customers need these functions, that probably they can have some other alternative solution like CEC monitoring and redundant connections between CE and PEs. So there are alternatives technologies already available. Why to complicate SR? One of the advantages of SR is that simplicity for the transit node. So why to break it? Because effectively you're proposing to go back to RSVPT.
No, this is not so compared to us, RSVPT, I think the more states, and this one, the states maybe is less than.
No, you still, again, you still need to monitor your backup, because you cannot monitor only working path. You need to monitor your backup, because backup might go down. So again, you're creating hell of a lot of new state and complexity I think that I suggest let's better first to discuss whether this complexity is justified.
Yeah, I think it's not that complicated. It's just.
I'm saying that again, if you introduce backup,
So you mentioned that. So
backup path, you need to monitor it because backup path might become unavailable.
You mentioned that we need to monitor the backup path. I think for the other protection ways, we also need to monitor the backup path, right? So either we monitor the backup path or we need to compute the backup path dynamically. So we have two ways, right? If we compute the backup path dynamically, and then maybe not fast enough. So in the other way, I think we also need to monitor the backup path, right?
Again, if you're advocating,
that's equivalent.
if you're no, it's not equivalent. If you're advocating dynamic calculation on an upstream node of backup for egress, I can say that with the same expediency can be done in a centralized controller or the head end and converged all things together. So again, I suggest let's build first, discuss the case, and then consider whether we need to solve it or not.
Please republish what you just said on the list so we can open discussion on.
I will. Thank you.
Thank you.
Peter Pshenak, Cisco. So contrary to what has been said here, I think this is an interesting problem to solve. The problem with your proposal is that it only works if you have the same worth on both PEs, which may not be the case because you are actually protecting the locator. And the second thing is this may work for a DT sits. For a per CE sits DX, this would require some kind of synchronization between the PEs, how they assign the labels. So there is more work to be done. I think I agree with the problem statement, but this proposal is far from being complete.
Yeah, I think that is our first version, and then we will enhance, and then as we receive more comments, right?
Okay, Jiedong from Huawei. Actually, I think this is a good idea to solve this use case, and I think the key difference from the RCPT-based mechanism is we don't introduce per path state into the network. Actually, you can monitor the backup path, but you can also use other ways to protect the backup path also. So this is about OEM, not the state in the forwarding plane, right? So.
But why do we need to protect it using the IGP here? BGP, you can advertise the backup path because you will learn the prefix both from PE3 as well as PE4. So PE1 already have two, primary and backup path through BGP. So these are already resolved in SRMPLS or anywhere else, right? So if you have a C dual home C, and there's PE3 and PE4, both will advertise a VPN prefix, and PE1 will already have two paths. And if the PE3 goes down, then it will work, right?
Yeah, I think maybe different, right?
No, it's different, but it's already solved, right?
I think this one maybe this one should be faster, right? This one.
No, but here also you have to come to know that PE4 is going down on PE1, right?
Thank you. Exactly my point.
Yeah, I think you're talking about the P1 to switch to another backup path, right?
Yes.
But this one is for the local protection, not for end-to-end.
Yes, that's right. Yes.
Local protection where?
On the P node.
Yeah, this one is a local protection. This is local protection here. So that's and then the faster maybe maybe some convergence or maybe slower.
But why we need to do this way?
Okay. Which failure you detect from where to where? How you detect the failure?
So this one, so P1 will detect the failure of PE3.
No, you would not detect the failure to P3.
Why not?
The thing is that you don't care about P3. What you care about P3 to CE2, because that's your connection to CE.
So here we talk about the protection of PE3, which is the egress node of this SR path. And then when this PE3 fails, and then traffic will not reach to destination CE2, right? So with this fast local protection, PE1, because PE1 is direct adjacency of PE3.
But
So PE1 can quickly detect the failure of PE3, and then it can quickly switch the traffic to the PE4.
But
then
PE3 can be perfectly
perfectly
PE3 can be perfectly fine, and PE3 and CE2 connection failed. So
yeah, no, yeah, we talk about this one in the equal production in R50. So that's another scenarios.
no, it's the scenario. That's ultimately what it should be about, because
I think this failure of this one, we talk about in the MPLS or TIS group a lot. So I think here we focus on the failure of this one. So I think if this one failure, I think there are different ways to resolve this one.
and again, you only you cannot differentiate the node failure from the link failure. So you can have multiple hops between P1 and P3 in the segment routing, because you can have combination, so loose strict routing, and there will be multiple nodes between P1 and P3. So that would be a tunnel, and you don't know what failed in a tunnel. P3 can be perfectly fine.
Yeah, those scenarios I remember we also have a detailed discussions when we talk about the egress protection in the TE. So you mentioned that, so when we detect the failure, and then we may have the failure in the tunnel, in our link, but the node is still there. So if we can have,
we're
have
gonna,
that capability, so
we're going
just
to cut off the line here and the discussion. So this is really good discussion. I think, so personally, I think it's a problem that does need solving. If the people, we have a couple minutes, but let's just, we'll cut the line, let the two people speak, and then continue to the next presentation.
I was just going to say that if it's P3 to PE3 anyone's worried about, regular FRR will fix that. So that sort of fault should be repaired. It would take 2 failures for FRR not to fix this problem.
So this is Himanshu from Siena. I think there are a couple of things here that has been said at the mic. If you are doing BGP pick, and if your PE3 node goes down, if you're doing multi-hop IPBFD, it will automatically switch to PE4. But if your link if your link to PE3 to C2 goes down, then you have the withdrawal, and that will take some time. So that in that particular case, you can have this egress protection. This egress protection will not work there because P3 node is fine. It is the P3 to C2 link has gone down. So this has a limited scope in that sense. As far as the backup path is concerned, that mirror seed is already programmed as an alternate next hop when P1 detects the failure to the link to the P3 or the node of P3 node failure, maybe then that case work. But there are other solutions to handle that as well. That's all.
Okay, thank you.
So there's a lot of work done in this area. Peak draft is here. There's another RFC and MPLS working group talking about egress protection. Would be good if you review them and. Okay.
Well, yeah, that's a good idea because we already have lots of discussion for the egress protection in TE, and then we can borrow something and then.
But this one is service aware, right?
Yeah,
so because you're connected to CE.
Yeah, that's
so
right.
So would be really good if you start discussion on the working group list to discuss the draft in details.
Yes, yeah, good.
Thank you.
Thank you.
Okay. Shu Ping from Huawei. First, thank chairs for allocating this slot for us. Appreciate. And here in this draft, we are considering the IPv6 encapsulation for PaaS services. Okay, so as we know, SFC and IFID, they are important PaaS services. And for each PaaS service, there's encapsulation header has been defined. For example, the IFID encapsulation, there is a IOM header, PBD header, and as well as the IFA. So just moved from the 6-man session, it seems in that room, people has got consensus that we need to carefully consider the design for the IPv6 encapsulation for example, IOM. So here, in this piece of work, we are doing the same thing. So we are considering, we are trying to analyze the problems and also the potential challenges are going to put in the data plane. And we are trying to find out the possible optimized solutions here with the help of the community. The next one. Thank you. Okay. So just to give an example here is the IOM. So we see this is the IOM packet. And in the tracing mode, if the packet traversing along the path, the IOM data is going to become very large. And if we put that data into the hop-by-hop or DOH option headers, so in the right part of the screen, that we show that is the IPv6 extension header order recommended in the RFC 8200. So those two option headers are before the RH. So in that case, as the data becomes very large, we're going to push the RH out of the parsing depth and out of the parsing window in the chip. So that will impose the challenge in the hardware and reduce the forwarding performance. And also, another point to think about is, with the introduction of the SRv6, so we would need to distinguish the IPv6 path and SRv6 path. So why this matters, we need to consider the optimal location to place those data. And the third point is the metadata. Currently, they are recorded separately for IOM, IFA, and there might be some redundant or inconsistent metadata exist. And also for the future, we need to consider the extensibility for the future proposed PaaS services. Next one, please.
Would you like to take a question now or then, Mr. Joel?
I'm Joel Halpern with Ericsson. I have a couple of concerns with the basic premise of this work. My objection is not to the particular format, bits on the wire, bits on the wire. First, we have multiple encapsulations. This is an unfortunate reality, but it is the reality. Making up yet another one has never solved the problem of too many standards for something. We have too many tunnel encapsulations, so we make up more. I don't like it, but I've never seen make up another one cause us to stop using the others. In the particular case of SFC, the point of the SFC work, and I brought this up when a yet different proposal for carrying metadata and path information was brought up in the Spring Working Group. The point of SFC was to provide a common transport-independent encapsulation of path identification and metadata. It works across SRv6, SR-MPLS, conventional MPLS, Geneve, IP encapsulation, you name it. It works. The whole point of the design, the reason the working group was chartered, was to get an interoperable mechanism so we didn't have an n-squared problem, that we had an order n problem. Creating a specific SRv6 encapsulation for carrying that information precisely undoes what the community agreed was important when they chartered SFC. And I would like folks to consider that when evaluating this work.
Yeah, sure. Thank you for your comments. Actually, we have been collecting feedbacks and comments over the IETF 104, also even before that. And this is one comment. I think the SFC case is a special case, needs additional thoughts here. So we agree, and in the future version, and we need to take into your comments.
Robin Huawei. So Joe, I would like to can you clarify the existing the SRH, this the header, is there any draft to talk about how in the IPv6 data plane, how it to be encapsulated? I'm not sure this one. This in SFC working group or the 6-man working group? And
If I may, Joel Halpern again. The SFC working group does not own the problem of defining transport endcaps. We were specifically chartered to stay out. We just completed in the MPLS working group a draft on carrying NSH in MPLS. If somebody wants to work with, I'll be happy to work with somebody if they want to do a respin of that that does exactly the same thing in a nice short draft, which we can progress very quickly once the SRv6 base is done, on how to do exactly the same thing with SRv6, because it's just carry it. And Andy held the pen on the MPLS one. It was very easy. That's why it's already been approved for publication as an RFC in the MPLS case. That particular one works for both conventional MPLS and segment routed MPLS. So we could do one that worked for IPv6 that worked for conventional IPv6 and SRv6. If somebody wants to work on that, fine. It's an easy draft.
okay, thanks.
Okay, I will continue. So here are some design considerations to optimize the path service encapsulation in IPv6 and SRv6. So basically, the key point here, we are trying to propose here is to separate the path service encapsulation into two parts. So the instruction part and the recording part. So the instruction parts will be put in the service option is what we proposed. That can be taken as a uniform IPv6 service option. And we recommend to place it in the front part of the IPv6 extension header, including the hop by hop or RH. And if it is a IPv6 path, we recommend to put it in the hop by hop. That means it's going to be processed by all the IPv6 enabled nodes. But for the SRv6, we would recommend it to place it in SRHTRV. So the benefits of doing this is we could keep the header part fixed, relatively fixed, as much as possible, and fixed and small. And in that case too, we could facilitate the hardware process and to keep the forwarding performance to some level. And another thing is we would like to propose is the IPv6 metadata header, and that is to contain the recording part. And it can be taken as a unified container to put the service metadata of those path services. And that could be placed after the routing header. So the benefits of doing this is when you realize there are too much data in the too much metadata in the packets, so you could choose to stop recording, and so that could avoid reaching the hardware limitation. So this next, please. And here are the service options we have defined. For example, the IOM service option, PBT, and IFA service options. And this is the places we recommend to place those service options. Next, please. Next, please. And here is the IPv6 metadata header. And here's the structure. And also for each service type, we could have this service metadata to contain the data. Next, please. So this is the key takeaway message. Just to repeat here. We are trying to propose to separate the path service encapsulation into two parts, and one is service option, the other the IPv6 metadata header. The benefits of doing this, we could keep the header as short as possible and also fixed. So in that case, we could keep the performance, the forwarding performance on the data plane. And also in that case, we could have the capability to choose to stop recording the metadata. So next, please. Next, please. So your comments and questions are welcome. And the next step for the draft, we would like to consolidate the comments we have received and also the future comments. And we will refine the drafts. Thank you.
So, comment as a working group member, recomputing lengths at every hop will severely affect your performance, I think.
Sorry.
You introducing recomputational function at every hop because your length changes. It's reasonably deep in the header. You would need, it's fixed offset, but still it's deep. So you need to recompute, you need to write it, and do it at line rate at every packet.
Yes.
Something to consider.
Yes, we agree. But the difference here is to for the data, metadata to insert into the packet, we just need to do the write without reading. So that is the difference. When you have the offset, you know where to insert. So that will be very quick. So so let's take it in this way. If we want to do the IOM, we have to put or insert data somewhere in the packets. And the thing here we are trying to do is to find an optimized way to keep the forwarding performance with the consideration that somehow it's going to damage. So that is the considering. Thank you. Thank you.
Okay, Greg Mirsky, ZT. I need to remind that if you add something in a packet, you need to recalculate the checksum. Okay, so that's one of the points. Another point is that, again, putting in a packet has a lot of limitations. One of them is how you protect the integrity of the data that you put.
Sorry.
So how you do data integrity protection in IOM?
I think that belongs to IPPM working group to work it out.
Okay,
no?
you are proposing it. So how you think it should be done? Are you putting their data without authentication? Without protection? So if you do protection, then you have extra in the wire speed. You need to do I don't know, SHA 256 on the data at the wire speed. Right?
Okay.
So I think that you need to be very careful proposing adding something in a packet. I think that we need to consider other option how to collect on-path telemetry. And there are already proposals. Okay.
Yeah, can I ask another question?
Name and affiliation.
Sure, please.
Your name and affiliation.
Cheng Li from Huawei. Because the problems mentioned by Greg are the same to all the IOM solutions.
Yes.
Yeah. So.
Yes. So that's why it belongs to.
But if you are proposing to IPv6, then are you proposing to introduce a problem, or are you proposing to have a solution?
Basically, we are going to propose a solution, but sometimes we need to solve some problems. But step by step, right? So I suppose, yep.
Again, if you're proposing solution that has a problem, then you're introducing a problem.
I disagree. So here we
It's
talk
becoming
about the
philosophical.
So the security, I think we have two parts. One is, you mean the security of the data. The other way is the way to do it, to process the data will impose some security risk, right? So I think in the IPv6 header, there is already the authentication, I mean, the other headers to do this. And also in the SRv6 DRV, they have the solution to fix the security problem.
Okay, I will close it on suggestion to authors to think about this problem and consider possible solutions.
Okay, acknowledge.
It's a bigger
Thank
problem
you.
and definitely belongs in IPPM, and we do know we need to provide solution transport, in-band telemetry on one side, another side. So, Greg,
Again,
it really belongs in IPPM.
yeah, it's an open question where it belongs because it might end up in 6-man.
Exactly.
Okay, thank you.
Good morning, everyone. I'm Yingzhen. I will try to do this quick. So this is an update of the policy YANG model. Okay, so since last IETF, we have 2 revisions, but the changes we did are all editorial changes. So we changed some descriptions to make the text more clear. And then we added some like detailed description in the model, just to make it perfect, ready for publications, including adding references. So with that said, that means the draft has been stable. We didn't really change anything in the model. The only problem right now we are having is right now the draft is showing errors because of the tool is now picking up those models we have a dependency. So we are using some IEEE models, the IETF tool that is now picking up those. So I don't think the ops directors are now here. So I guess this is an IETF issue. We probably want to fix those tools.
Ignace, may I ask you?
Ignace here. So this sort of thing is not only just impacting this model, it has some.
Ignace Bogdanas. Actually, I cannot say that I'm aware of what precise problem is here. I'm seeing now, trying to read that, and it appears that some interrelation of what you are importing from somewhere else.
Yeah, because we are importing IEEE data models for this specific case. So what we are really using is the interface VLAN model, and that one is actually importing IEEE model. So that one also shows error. And then further, because we are importing that one, so this one is also impacted.
So this appears to be a coordination problem between the different SDOs, right? From the reading of my side. Yes, that is something on a big to-do list that needs to be resolved. If you want an answer today, there is no answer for that, but this will be looked at.
Yeah, sure. We can take this offline, figure out. This is a general problem for the, also impacts other models. So, so just for the policy model itself, I think we are ready for publication. So after this IETF, we'd like to formally request the Young Doctor review and then working group last call. This one. So that's it. Any question for the policy model? If not, then the next one. Okay, so this is actually a RIP extension model, the one to extend the model defined in routing the RIP defined in routing config model. So this one just became a working group document. But before this IETF, we actually have this model for 3 years already. So although it just became a working group document, but the only changes we did before this IETF are editorial changes. We also add some combined tree diagram from this IETF routing config in appendix. So we plan to add more examples just to help people understand how to use this model. But the content of this draft is complete. So we want to collect more review comments and start a young doctor review, and we'd like to progress this model soon. Maybe after the policy model, we would like to last call this one.
Thank you.
Thank you.
Yunan?
Hello, everyone. This is Yunan Gu from Huawei. So today I'm going to discuss the use cases for the control plan telemetry. We'll use the term network-wide protocol monitoring to refer to the control plan telemetry. Okay. So as there has been some existing works on management plan and data plan telemetries, such as IPPM, IOM, and NetConf, gRPC. And for the control plan, there's also some work going on, such as BMP. And here we have clarified major two categories of applications or say use cases that we can use the control plan telemetry for. The first one is it can be used for network troubleshooting. And as the statistical figures show in the right part, there's a very large percentage of network issues were caused by protocol failures. And so with monitoring and analysis of control plan data, the detecting and root cause analysis of the issues can be improved. And then the other type of applications would be network planning. So with more, for example, with more detailed route information, you can have better route optimization and stuff like that. And another thing is that with route policy information correlated with route attribute information, you could do applications like route validation and yeah. So we'll discuss some use cases, and before that, here's the problem space that we discussed for each use case. So starting from the data generation, the data source types are discussed, and also the network device coverage are also discussed here. So for example, what type of data should be retrieved from what devices. And then it comes to the data processing, the data encapsulation, serialization, subscription. So in this part, the processing efficiency should be considered, okay? And then it should be transported with proper protocols, existing ones like BMP, gRPC, NetConf, and so on. Of course, performance should also be guaranteed. And then it comes to the data analysis at the controller side. In here, the analysis is very application specific, and the problems such as data synchronization and data correlation, because we might have multiple options and data sources. So these questions should be considered during the data analysis. Okay, and two use cases very quick. The first one is sorry, I probably sent you the wrong slides. That's not the one I'm going to present. Let me see. Okay, let's use this one. So the first use case is the Stp synchronization failure. Okay, so well, there are some cases, for example, an LSP authentication failure. For example, in this case, the device may have some diagnosed information, and it could be retrieved from the device and sent to the controller. But in other cases, for example, there are software or hardware bugs. In this case, the device is not capable of diagnosing the issue. So in that case, the LSDB and also the sent and received LSPs are required to be collected and compared to localize where the issue actually happens. Okay, and then let's see. Okay, let's use this one. So another example that I want to discuss is the validation of root policies. So currently, policies can be exported using either gRPC or netconf with EM models. However, it's not sufficient to do policy validation. You need to have the way to correlate the exact policy processing with the policy, with the root attribute change. Okay, so with such correlated record, then the operators can have a very clear vision how each policy is exactly changing its roots. Okay, and that helps with the troubleshooting and also the validation of your policy. And also, all right, let's just stop there. Okay, so there are more use cases in our draft, and if you're interested, please read the draft and provide some comments for us. So here's a quick summary from the use cases. We think there should be a tunnel for the control plan data to be exported. So when building this tunnel, the data processing performance should be guaranteed per specific use cases. And then the second requirement is to guarantee the data type coverage, because some data has already been is able to be exported nowadays. Okay, and also the device coverage should also be considered. So that's it. Any question or comment?
So I'm very sympathetic to the use case, very much needed. The question is, how do you establish your intended state? Because you're gathering operational derived states.
I'm sorry.
You're gathering operational and derived state, but
Yes.
you need to be able to compare it to what it should be. How do you see establishment of baseline of intended state that the operational state could be compared to?
I'm sorry, I couldn't quite understand. Couldn't hear it very clearly.
You're gathering information. You want to use it somehow. It should be actionable, right?
Do you mind translate this question?
I'll discuss with you offline.
All right, thanks.
So Andy is up next.
First of all,
AC Lynn, just
oh, sure.
Okay, sorry. This is regarding the prior presentation. I mean, I'm not questioning the need to debug networks, but it seems like we're doing all this work to reduce flooding in LSR, and here you have a proposal to collect every link state packet and everything from every router in the IGP domain. I think it's, I think you could do something that was a lot thinner with an IGP than what was in this picture that I just saw.
I mean, that's useful, but at the same time, I think that was actually from an actual customer use case that large networks find it useful to actually compare as a, kind of like a third-party check, kind of like traffic lights have circuits.
Like BMP for ISIs.
Yes, yes.
I know what it is. It seems like it would, granted, links are faster, CPUs are faster, memory's cheaper, but it's going to significantly increase the overhead to do something like that.
True. However, I mean, the application space for the flooding reduction is data centers in general. Right. And this may have a different application space like WAN networks.
Okay, accepted.
Jeff, I was just in follow-up to AC's comment. A lot of the use for telemetry for the IGPs is to get access to IGP data in a safe fashion. In a lot of cases, tapping into an IGP protocol-wise puts you in a situation where you could accidentally inject state into the network, which that's a bad thing.
Okay, I'm Andy Malice. This is a draft that's being written by the combined chairs of the MPLS and PALS working groups. So I'm presenting on their behalf. This is a reprise of a talk that I gave earlier this week in the MPLS working group. So the goal here is, let me give a bit of history. LDP was first published in January 2001, RC 3036. It replaced, as it progressed on the standards track by 5036 in 2007. LDP specified the use of TCP MD5 signature option for the authenticity integrity of LDP messages and to prevent against LDP spoofing, and that is still the case. That has not changed. However, as far back as 1998, the IETF has been aware of problems with MD5C, for example, RC 2385. So in 2010, we wrote RC 5925, which deprecated the TCP MD5 signature option and replaced it with the TCP authentication option, TCP-AO. And then there's a companion RFC which actually specified the cryptographic algorithms such as AES 128 or 256 that you could use with TCP-AO. And then RFC 7454 in 2015 took the step of deprecating MD5 for BGP and replacing it. Oh, I also missed a step. RFC 6952 in 2013 recommended that all TCP-based routing protocols, which includes BGP and LDP, for example, but there are others as well, move from MD5 to TCP-AO, and that happened for BGP in February 2015 when RFC 7454 deprecated MD5 for BGP and replaced it with TCP-AO. However, LDP continues to use MD5. So that brings me to my last slide, which is the goal of this draft is to do the same thing for LDP that we did previously for BGP, which is to deprecate MD5 and replace it with TCP-AO. However, we, the combined authors, are really much more LDP experts than we are security experts. And we have some questions that we'd like to throw open to the audience here. We wanted to give it a wider audience than just the MPLS working group. The first is, how successful has TCP-AO been for BGP? Is TCP-AO actually used in the field for BGP? We don't know. Do any of you know? And here comes Jeff Haas.
Hi, Andy. I'll state for the record that the routing ADs had asked me and a few other people, sorry, can you hear me now?
Yeah.
I'll state for the record that the routing ADs had asked me and a few other people to try to put together the status of things and some notes for the security group almost a year ago now. There's been no cycle, so that's not actually happened. But to answer the specific question here, TCP/AO is finally starting to see deployment. Now we're seeing it from at least one vendor. That is not my employer. That said, we don't have experience in the field to see how well it's working, but at the very least, it's starting to show up. So that's good. Problem that you have, unfortunately, is that TCP/AO protects 1/2 of LDP. LDP's got obviously the transport session they carry all the state, but it's also got a hello mechanism as well.
Right.
So the problem is TCP/AO is only going to cover half of your story. What are you doing for the other half?
Right. But it's still better than MD5.
Well, again, what are you doing for the other half of the story?
Yeah.
Because that's still an attack on the protocol.
Absolutely. Okay, cool. Thank you. So it's certainly good to know that there is some use of TCP/AO for BGP out there. And Alvaro?
Alvaro Rotana, I just wanted to correct a little bit of the history. You said that 7454 deprecated MD5. It didn't really. It didn't update the base spec or anything else. All it said was if TCP/AO is available, it should be preferred. And actually, a couple paragraphs later, it says that protecting the sessions is not required.
Oh, okay.
So, yeah, I tried to go further into saying that we should do better than MD5, but I don't think it was strong enough at that point.
Okay, thanks. So perhaps we can do better for LDP. Eric, do you have a comment?
Yes, Eric Gray, Erickson. I had asked this in an earlier presentation of this particular thing, and I don't think I really got a good answer. It seems to me that this is AO is a TCP thing, and if you build LDP on a device that has TCP with AO support, I'm wondering what additional support you need to do.
That's probably more of an implementation question than anything else, I think. It's not a protocol question.
Yeah, I don't have a problem with writing a draft that explains how that's done. I'm curious as to what extra work had to be done. And the answer doesn't seem to be coming forth.
Right.
Jeff Oz, again, it's worth pointing out that AO solves the TCP type problem. If what you're really trying to do is add a layer of security on top of it, it may be time to play with IPsec. IPsec's not my favorite chainsaw to use for security. It's very tricky to use. And the majority of the headache is figuring out how to configure things. But it does cover both streaming protocols like TCP and also datagram protocols like the UDP discovery component. You can do both things there. You can actually use static security associations if you really wanted to. You can use IKE if you actually wanted to do things. The challenge that IPsec has is not that it's not an appropriate tool to get it working, just that the way security people really want to use the thing tends to push you into interesting chicken and egg type problems for protocols, which the whole point is to get the network up and running.
Right.
A little bit of that stuff was covered in the CARP working group back in the day. There's some notes, I think, that covered LDP in that circumstance that's worth scraping through. But my suspicion is that if you were to take some random sets of LDP implementations and spend probably a couple of days worth of fiddling, you could probably get IPsec to cover every situation you really need if that's really your concern.
Cool. Now, if I can ask you to stay at the mic for a second, because you may have input on my next question, seeing as you already stated that you're aware of some use of TCP/AO in the field for BGP. The next question is, assuming that we do this for LDP as well, which crypto algorithm should we choose? There are a choice, for example, one that's been suggested as the common state of the art right now is AES 256. But then my question is, if you want to do LDP in a cheap, inexpensive PE router at the edge of the network, can that, so, does that have enough horsepower in the CPU in order to be able to support something like TCP, like AES-256 for LDP messages?
Yeah, so I don't actually have specific experience with individual algorithms, and like I said, my employer does not implement it. My general experience with cryptography in these types of circumstances is that the primary use is to burn your CPU for non-useful purposes. Security people are looking to provide appropriate level of coverage for things, and sometimes the attack space is unclear to them, and therefore the solutions they offer are sometimes rather heavy-handed. So to offer easy example, BGP, you have eBGP, direct connections. Securing a link that transport session runs over is often enough to provide the necessary security. Providing TCP on top of that is exercise they tend to call defense in depth. Sure, it's good to run it, but you're less motivated to do so when the transport is covered that TCP is on. However, BGP also does IBGP, which crosses your AS, which you don't want customer to be able to do bad things to your internal sessions. Similarly for LDP, your core use case in a lot of circumstances is just simple, between pairs of routers, and therefore the necessity of covering the session is not quite as challenging, but also for like targeted LDP for other circumstances as well. What you really need is a strong enough cipher to provide protection against the key things. The original motivation for BGP when the RFC was written was TCP reset attacks.
Right.
And we don't see those things quite as much anymore. We tend to see more volumetric type DDoS at this point instead. If you look at the attack space you're trying to cover for LDP, secrecy is potentially not something you're looking for. That's one of the things. It's like, so like even you're using IPsec, authentication header might be enough to provide you all the integrity checks to keep your session being blocked. The additional security you'd get from a cipher to provide secrecy as a property may be overkill. It pretty much comes down to, do you care if somebody actually sniffs on your labels or not? Some cases you might do that. You might have some three-letter agency that actually cares about such things. But the other thing that TCP/AO gives you, aside from just simply the ability to use better ciphers, is it gives you cipher agility. And a common property for cryptography, and this is where you go find real cryptography, give you the real story about things, is that you want to use something that's strong enough for the lifetime that you care about. If you're trying to provide end-to-end secrecy over a huge amount of time, you're using the strongest cipher that you possibly can with all the consequences. If you're trying to provide just integrity of things, you use a strong enough cipher that's protected, that will protect you over a reasonable period of time. And if you're rotating your keys on a reasonable enough basis, they may not be able to catch up with you before you've actually changed them out. So a lower horsepower cipher may get you exactly what you need as long as the key rotations work appropriately. In the case of TCP/AO, that mechanism is there. In the case of IPsec, IKE is unfortunately the mechanism they use.
Okay, thank you. Himanshu is next.
I just wanted to follow on directly from Jeff, because the question I've been asked, this is Stuart, I've been asking for around here, and I don't know who to address it to, is if we spun the MD5 key often enough, would that be good enough? And how often would we need to spin it so that the security ADs would be happy? Because since we originally did these designs, we're no longer running routers with scripts that stay there forever. We're in a world where network management systems and SDN systems spin this sort of config all the time. So what is the secure lifetime of MD5 that we need to worry about?
Normally you'd say I'm not a lawyer. In this case, I am not a cryptographer. Part of the answer that I'm aware of is covered by two things. There are known semi-real-time attacks against MD5 as a cipher at this point by cryptographers. You can have big enough horsepower boxes to do this sort of thing, and even with the HMAC MD5 that's recommended these days, cryptographers tell you don't do that. Just a weak cipher at this point. But the second half of the observation is the existing TCP MD5 provides no mechanism for key rotation. So the side effect of that is if some implementations may allow you to use coordinated clocks to try to swap out your ciphers at an appropriate time. You configure effectively key number 1, key number 2, and a time X coordinated by a clock. You start using validation against both ciphers. Once you actually see the new cipher validating, you drop the new key validating, you drop the old key. So there are mechanisms that are deployed that allow you to get that sort of thing, but they don't always work very well. And the consequence of them not working is that your BGP drops, and we know that BGP dropping is bad. The whole point of TCP/AO is that it provides the necessary protocol plumbing so that this stuff can happen smoothly.
Okay, thanks. Himanshu.
Himanshu from Siena. So I'm glad you are bringing this thing up and good discussions. What I wanted to find out is your goal is to then come to a conclusion and make a definitive recommendation for whether to use drop MD5 and use HMAC MD5. I think HMAC MD5 is becoming more as a replacement. So, I mean, there are things ongoing. I think we need a conclusion as soon as possible.
Okay, thanks. And that actually comes up to my last question, which we got some kind of, we did get one answer in the MPLS session. So my last question was, does anyone really care? And is anyone currently using MD5 with LDP in the first place? And it turns out the answer is yes. From at least one vendor reported that they know of at least 10 of their service provider customers that are actively using MD5 with LDP. But the question is, are they aware of the problems with MD5? And of course, we don't know. But MD5, for whatever reason, is in use in the field with LDP.
Andy, so Stuart, are they using it as a super checksum, or are they using it for security?
We do not know.
Because I know that in the LSPs, a lot of the use of MD5 of the crypto piece was just as a better checksum.
Yes, we do not know the answer to that question. So anyway, I think that this has actually been quite successful in terms of presenting both MPLS working group and here. We got some really good feedback. It looks like there is reason to continue this work. One of the questions we were asking these questions was, should we continue the work? And it looks like there is reason to continue the work. And I think we have a good consultant to talk to now to help us with that. So thank you all very much.
So as a working group member, MD5 is deployed. I used to work for a number of vendors, and we've seen it significantly deployed. And when the issue of MD5 flaws brought, it's an interior protocol. It doesn't leak out, so we don't really care. So it would be quite difficult to get operators to do something proactively in this case. It's personal opinion.
Okay, thank you. Any other questions, comments? Okay, thanks.
Thank you, everyone, and we will see you at IETF105. Safe travel. Now you know.